Hello everyone, welcome back to my channel Tutelage, a guide to learner. Here, this is Sriparna. Hope all of you are doing well. We have already discussed different topics under the chapter that is Measures of Dispersion. If you are missing it, so go and check out my channel once. Channel's link is in my first comment and my description box. Today we are going to explain rest of the topics of the same chapter. So that's why the session called as uh, Measures of Dispersion part 6. Okay, so and this is the last session for this chapter also. So now go to the next slide. Here we can see some topics which we will discuss today. So first one is calculation process of the standard deviation in the discrete and continuous series both. Second topic is discussion on the relative measure of dispersion. We have already known there are two different ways of measures of dispersion. First one is absolute measures of dispersion and second one is relative measure of dispersion. So today we are going to explain the second kind of measures of dispersion, that is relative measure of dispersion. And third one, this is one of the most important topic of these chapters, so that's why Lorenz curve. So Lorenz curve is the third one which we will discuss today. So learner, move on the next slide or the main slide and let's start the session. We have already known there are two different ways of measures of dispersion. So first one is absolute measures of dispersion and second one is relative measures of dispersion. So in my previous session we have already discussed different types of absolute measures. If you have missed, please go and check my previous sessions, and if you are facing any problems regarding these, please let me know and please do comment in my comment section. At first we have to discuss the calculation process of the standard deviation, so that's why move on to the next slide. So at first we have to know what do you mean by a standard deviation. So standard deviation is basically the square root of the arithmetic average of the squares of the deviation measured from the arithmetic mean of the data. So basically standard deviation is the average of the squares, okay, which is known as variance, and the square root of variance is basically standard deviation. So standard deviation is the square root of variance, okay. So I think this is clear and in detail we have already discussed it. So now going to the estimation or the calculation process of the standard deviation, okay. So now move on to the next slide. So here this is the formula of the standard deviation, and without frequency, the formula of the standard deviation, which is this is known as sigma. Sigma is equals to root over summation x minus x bar whole square divided by n. N is the number of frequency, and with frequency summation f d square by n minus summation f d by n whole square. Oh, and this is a square root. Okay, so root over summation fd square minus divided by n minus summation fd by n whole square. This is the formula of the standard deviation. So now move on to the next slide. So here we can see the estimation on or the calculation process of the standard deviation, which follows in the discrete series at first. So now going to the problem. So problem number 9 is the calculate the standard deviation of the following series. So there are two columns. First one is indicates the roll number of the students and second one indicates the marks of the obtained marks of the students. So 1, 2, 3, 4, 5 and the marks are 5, 7, 8, 9, 11. So now going to the next slide, and this is the calculation slide basically. So now move on to the next slide, and here we can see some steps for uh, calculation for solve the problem, for solve the particular problem. Okay, so the first step, at first we have to calculate the mean value of the series. So average, so that means mean value. So at first we are calculating the mean value of the series. Okay, step number 2, we are taking deviation of the items from the actual mean. So that is x minus x bar. Okay, so x bar is the small x bar is the actual mean. Okay, so at first we have to calculate the mean value, and now going to the second step, we are taking the deviation from the actual mean. That means x minus x bar, and which is denoted by the deviation by which is denote these deviation by x. Okay, so now going to the step 3. So square the deviation and denote the total summation x is square, because square the deviation. So x minus x bar, which is known as x. So this is so x basically x minus x bar is indicated by small x. Okay, so square the deviation, that means summation x square. And now going to the next step. uh, so step number 4 is multiplying the deviation by their respective frequencies and take their sum total. So if x is square, so x is square and multiplying the deviation, deviation is x is square, and multiply, which is multiplied by the respective frequencies, that means f. So f into x is square, and now going to take their sum. So that's why summation f x square. Okay, and now going to the last step, applying the following formula to calculate standard deviation. So I think this is clear. So at first we have to calculate the mean value. Now going to the deviation part, and third step, that is square the deviations and uh, take their sum. So that is summation x square. Step number 4, we have to multiply the deviation by their frequency, so and take their sum total. So that means summation f x square. And now going to the last step, that is applying the standard deviation formula. Okay, so learner, now move on to the next slide. So here we can see the solution portion for the particular question. So we can see there are 4 column, 1 2 3 4 6. Okay, so there are 6 columns. So first column indicates the roll number of the students, second column indicates obtained marks of the students, and third column indicates f into x. Okay, so if x, that x indicates the deviation. Okay, so deviation is equals to x minus x bar. So first value minus the arithmetic mean. So at first we have to get the arithmetic mean. So that's why we have to calculate the fx column first. So phi fx. So if marks is indicated by small f and roll number is indicated by x. So f into x, that means 5. Second one is 7 into 2, that means 14. 8 into 3, that means 24. 4 into 9, that means 36, and 5 into 11, that means 55. So all total is 134. So fx by summation fx by summation f, that implies the arithmetic mean, that implies the formula of the arithmetic mean. So summation fx, that means 134, and summation f, which is equals to capital N, this is known as 40. Okay, so 134 divided by 40, that means 3.35. This is the value of arithmetic mean. This is the answer of the arithmetic mean. So now going to the fourth column. So the first observation, that is 1, and we can see 1 minus 3.35, because x bar or the arithmetic mean is 3.35. So that's why the 1 minus 3.35, that means the deviation value, that means minus 2.35. Okay, So second one, for the second observation, 2 minus 3.35, that means minus 1.35. Third one, 3 minus 3.35, so that means minus 0.35. Now going to the fourth one, so 4 minus 3.35, that means plus 0.65. And now going to the fifth one, so 5 minus 3.35, that equals to 1.65. okay, so these are the deviation value, okay, according to the roll number of the students. And now going to the next column, where we can see the value of the x square, the value of the square value of the deviation. Okay, so minus 2.35, this is the x value. So x square means minus 2.35 whole square. Okay, so that means 5.52 is the value of the x square for the first observation. Now going to the second one, minus 1.35 into minus 1.35, that means 1.82. Now going to the third one, minus 0.35. okay, minus 0.35 into minus 0.35, that means 0.12. And now going to the fourth one, 0.65 into 0.65, that means 0.42. And now going to the last one, 1.65 whole square, that means 2.72. okay, so for the formula, to calculate the standard deviation, we need summation f x square. okay, so that means we have x square, we have f values, so we have to calculate the multiplication value of the f and x square. okay, so now going to the last column, and we can see the value of the f x square. So x square is equals to 5.52 into what is the value of a for the first observation, that is 5. So 5 into 5.52, that means 27.6. Now going to the second one, what is the value of f, that means 7 into 1.82, that means 12.74. Now going to the third one, the f value, frequency, the value of frequency for the third observation, that is 8. okay, so 0.12 into 8, that means 0.96. Now going to the fourth one, 9 into 0.65, that is 0.42, that means 3.78. And now going to the last one, 11 into 2.72, that means 29.92. So the total is, the summation f x square is 75, and we have already known the formula of the standard deviation. So the formula is sigma is equals to summation f x square by summation f and whole square. okay, so summation f x square is equals to 75, okay, divided by summation f. What is the value of summation f? That is 40. okay, so from table we have already get summation f is equals to 40. So 75 by 40, root over of 75 by 40. So 75 by 40, that means 1. Summation 75 by 40 is equals to root over 1.875. So 75 by 40, that equals to 1.875. So square root of the 1.875 is equals to the answer of the standard deviation, and so the answer of the standard deviation is 1.37 approx. So this is the correct answer for this particular solution. I think this is clear. So learner, 1.37. okay, so the square root of the 1.875 is equals to 1.37, the approx value. Obviously it is the answer of the standard deviation, and this is the correct answer for this particular problem. So what is the calculation process when the distribution follows in a discrete series? Okay, so at first we have to calculate the fx value for the calculation for calculating the arithmetic mean, because the main step for this calculation, we are taking the deviation of the items from the actual mean. So at first we have to calculate the actual mean or the actual arithmetic mean. So that's why the at first we have to calculate the fx value, because arithmetic mean is equals to summation fx divided by summation f. And now going to the second step, we are taking the deviation of the items from the actual mean or the arithmetic mean, which is denoted by x bar. So small x is equals to capital X minus x bar. Okay. So and now going to the next step, square the deviations. Okay, so that's why x is square, and so next step is we have to multiply the deviation by their respective frequencies, which is f, and take their sum total as summation f x square, because the formula of the standard deviation is sigma is equals to summation f x square by summation f a whole root over. Okay, so that's why we have to calculate the the value of f x square. Okay, I think this is clear. So if you have any problem for the calculation process of the standard deviation of any absolute measures of dispersion, so please do comment in my comment section. So learner, I think this is clear to everyone. So now move on to the next slide, and where we can see the another problem which follows in continuous series. Okay, so here this is the problem. So there is a range basically for marks of the students. So 0 to 4, 4 to 8, 8 to 12, and 12 to 16, and number of students are 4, 8, 2, and 1. So now going to the next slide, where we can see some steps for the estimation process of the standard deviation. Okay, so now let's move on the next slide. So here we can see the first step. So what is the first step for the calculation process of the standard deviation? So the step 1 is finding out midpoints of the different classes. So at first we have to find out midpoints of the different classes. So 0 to 4. So now calculate the midpoint of the first class. Okay, so now going to the second step, we are taking deviation of the midpoints, which is denoted by small m of the class intervals, from the assumed mean, which is denoted by capital A. So the deviation value is equals to x minus a. Okay, and the deviation value is denoted by small d. So now going to the third step, we have to multiply them, so the deviation value, by respective frequencies to get the total summation fd, and calculating the square of the deviation, that is d square. So at first we have to calculate the multiplication, we have to multiply d, the deviation value, by respective frequencies, and now getting the total value, that means summation fd, and after that we have to calculate the square deviation, the square value of the deviations, the square deviation value, so that means d square. So at first f into d, now adding the all values of fd and get the summation fd value, and after that we have to calculate the value of square deviation, that means d square. Okay, so now going to the step 4, we have to multiplying this square deviation by respective frequencies and to obtain the summation FD square. So we have the value of d square, and in the step 4 we have we have to multiply the square deviation value by respective their frequencies, okay, and we are getting the total value or total of the all FD square value. So that means we have to get summation FD square. We have to get the value of summation FD square, and after that we have to apply the following formula to calculate the standard deviation, and the formula is sigma is equals to root over summation FD square divided by n, that means summation f minus summation FD by n whole square, okay. So now going to the main problem and main slide also. So here we can see the solution for the particular problem, and we can see there are 6 to 7 columns. So at the first column we can see the marks of the students, and now going to the second column which indicates the number of students. So 0 to 4, 4 to 8, 8 to 12 and 12 to 16. So now going to the third column, and we have to calculate the mid values of the first, second, third and fourth classes. So 0, what is the process, what is the calculation process of the mid values of the class intervals? So the upper class interval and the lower class limit, the summation of the upper and lower class limit divided by 2. So for the first class, 0 plus 4 divided by 2, that means 4 by 2, which is equals to 2. So the mid values for the first class, which is equals to 2. Now going to the second class, 4 plus 8 by 12, that means 12 by 2, that means 6. Now going to the third one, 8 plus 12, that means 20, 20 by 2, which is equals to 10. And now going to the last one, 12 plus 16, that means 36, 8 and 28. So 28 by 2, that means 14. So 14 is the mid values for the last observation or the last class, okay. So now going to the next step, we have to calculate the deviation value, and this is and 6 is the assumed mean. So capital A is 6, okay. So for the calculation process of deviation value, which is denoted by small d, for the first class, 2 is the mid value, that means small x, okay. So 2 minus 6 is assumed mean, that means capital A, so minus 4. For the second class, 6 minus 6, which is equals to 0. For the third class, 10 minus 6, that means 4, and for the last class, 14 minus 6, that means 8, okay. So now going to the next step, and we have to multiply the deviation value by respective frequencies, okay. So number of students is basically a frequencies. So this is the f value, these are the f value 4, 8, 2, 1, okay. So f into d. So for the first class, the value of d is equals to minus 4, and the frequency is 4. So 4 into minus 4, that means minus 16. Now going to the second class, 8 into 0, that means 0. Now going to the third one, 2 into 4, that means 8, and now going to the last one, 1 into 8, that means also 8. So what is the summation of what is the sum of the all FD's values? So minus 16, 8 plus 8, that means plus 16. So minus 16 plus 16, that means my summation FD is equals to 0, okay. So now going to the next column. So we have to calculate the square of the deviation value. So for the first class, the deviation value is minus 4. So that's why the square deviation value minus 4 into whole square, that means 16, 0 whole square, that means 0, 8 whole square, 4 whole square, that means 16, and 8 whole square, that means 64. So now going to the next column, and where we can we have to calculate the sum f into d square. Okay, so these are the d square, value of d square, and these are the value of frequency. So 16 into 4, that means 64. Now going to the second class, 8 into 0, that means 0. Now going to the third one, 2 into 16, that means 32, and 1 into 64, that means 64, and the summation fd square is equals to 160. Okay, I think the calculation process is clear to everyone. And now going to the last step, where we are applying the formula of the standard deviation basically. Okay, so now move on to the next slide. So here we can see from table we get already n is equals to 15, fd is summation fd is equals to 0, summation fd square is equals to 160. So the formula is sigma root over summation fd square by n minus summation fd by n whole square. Okay, so summation fd square, that means 160, so 160 by 15, okay, minus fd divided by n whole square. So 0 minus 15 n whole square, so 0 whole square, that means 0. So 160 by divided by 15, that means 10.67. So 10.67 minus 0, that means 10.67, and the square root of the 10.67 is equals to 3.265, that means 3.3 is the approximate answer for this particular problem, and this is the correct answer for standard deviation which follows in continuous distribution. Okay, I think this is clear to everyone. So now move on to the next slide. So we have already discussed absolute measures of dispersion, and we have already told today we are going to explain the another ways of measures of dispersion, that is relative measure of dispersion. Okay, so the absolute measures of dispersion is is measured in units in which the data are measured. Okay, so that is the basic differences between the absolute measure of dispersion and the relative measure of dispersion. A comparison of such measures of dispersion becomes difficult, meaningless, when dispersion of different sets of data is to be compared, since these measures are expressed in different units. So that's why in such situations it is generally the relative measures of dispersion which are used, where the different sets of data is to be where the measures all types of data, the measured data are expressed in different units. There is no common unit. Okay, so in such situation measures of relative measures of dispersion are used. Okay, so the relative measures are taken as a ratio of the absolute measures of dispersion with a corresponding average. So these measures are pure numbers, and it is defined in general by relative measures of dispersion, which is equals to absolute measures of dispersion and divided by average. So this is a ratio. So it is the ratio of the absolute measure of dispersion with a corresponding average, and this is known as relative measure of dispersion. I think this is clear. So now move on to the next. So here we can see there are 4 ways of relative measures of dispersion. The first one is coefficient of range, second one is coefficient of quartile deviation, third one is coefficient of mean deviation, and fourth one is coefficient of standard deviation. Okay, so let's move on the next slide where we can discuss the formulas of the coefficient of range, coefficient of quartile deviation, and so on. So now move on to the next slide. So the first formula of the coefficient of range, and which is the first way of relative measures of dispersion. So in the coefficient of range calculation, there is no strictly defined coefficient of range because there is no average of range. However, the coefficient of range is measured by dividing the range by the sum of the lowest and highest values. So H plus L as H plus L divided by H minus L. So what is the meaning of H and L? So H is basically indicates the highest value of the series, and L indicates the lowest value in the series. Okay, so the highest values plus lowest values we are putting as a numerator, and we are putting as a denominator the highest value minus lowest value, and this is the formula of the coefficient of range. Okay, so now going to the next way of the relative measures of dispersion, that is coefficient of quartile deviation. Okay, so Q3 we have already known. Q3 is the third quartile and Q1 is the first quartile. So the formula of the coefficient of quartile deviation, Q3 minus Q1 divided by Q3 plus Q1. Okay, I think the formula is clear. So and it will be more clear when we are using an example. Okay, so when we are using it by an example, so without example the formula of coefficient of quartile deviation, or the range, standard deviation, mean deviation is quite difficult for remembering. So that's why we have to know the formula of the, in this slide we have to know the formula of the coefficient of quartile deviation, third quartile minus first quartile divided by first quartile plus third quartile. Okay, this is clear. So now move on to the next slide. So here we can see the coefficient of mean deviation. Okay, so coefficient of mean deviation basically calculated by dividing the mean deviation of the series by its corresponding average also. Average means x bar. Okay, so if the deviations are taken from the arithmetic mean, the mean deviation is divided by the arithmetic mean. So thus the coefficient of mean deviation from the arithmetic mean is calculated by the following formula, that is mean deviation of the x value of the arithmetic mean value divided by average or the arithmetic mean. I think this is clear. So now move on to the next slide, next formula. This is coefficient of the variation. So coefficient of variation is the coefficient of dispersion, basically based on the standard deviation of the statistical series, and it is expressed as a percentage, and we can see the formula of the coefficient of variation, sigma divided by x bar into 100. So that's why it is expressed as a percentage. So the coefficient of variation is calculated by dividing the standard deviation of the series by the mean of the series, because x bar denotes the arithmetic mean and sigma denotes the standard deviation. So standard deviation minus standard deviation divided by arithmetic mean into 100, and the ratio is multiplying by 100. So the formula for estimating the coefficient of variation is sigma divided by x bar into 100, and that's why it is expressed as a percentage value. I think this is clear. So I think these are clear. I think there are four formulas. So coefficient of range, coefficient of standard deviation, coefficient of quartile deviation, and mean deviation, and all formulas are clear to everyone, and it will more clear when we are using it. Okay, so I think this is very easy for remembering. So now move on to the next slide. So here this is the one of the topmost topic for this chapter, that is the Lorenz curve. Okay, So basically, here we will discuss a short note on Lorenz curve, but in my next session we will discuss it in detail also. Okay, so what do you mean by a Lorenz curve? So Lorenz curve basically gives the graphical representation of the income distribution or wealth distribution. Okay, so it is the graphic method of studying dispersion. This curve is widely used to measure inequalities of income, inequalities of wealth, etc. And Max Lorenz was the first to make use of this curve. So that's why it is called the Lorenz curve. So learner, Lorenz curve basically gives a graphical representation of the distribution of income. Okay. So we will explain it elaborately in my next session, so stay tuned. Okay, I will come again with a new session. So today we have already discussed the calculation process of the standard deviation, which follows a continuous and discrete series, and the relative measures of dispersion, and a short note on Lorenz curve. Okay, so we are done for the today's session. If you like my video, so please do one like, one comment and one subscribe. Please do some support and subscribe to my channel for getting another new session. Keep commenting. Thank you all. Happy learning.